So you might be wondering where these various types or these variants or these alleles come from. So the answer is that variation is caused by mutations. And mutations has got a bit of a bad rap because we see it in superhero movies, and we know that mutations can cause these negative effects, or they cause these wildly superhero effects. And the answer is, well, actually in science, mutations are a natural process. It happens all the time. So mutations occur all the time because our DNA makes mistakes copying itself, our cells make mistakes, we're exposed to environmental factors that cause variation, that cause mutations, like X-rays or some types of chemicals and so on. And so mutation is a natural process that causes variation. And as an example, I want you to think about the waiata, the himene whakaria mai. Now, in most places in New Zealand, you'll hear it sung one way, but in some places you'll hear it sung to a different tune. So that is a variation in the structure or the melody of the waiata. So when it was originally composed, probably the first person who composed whakaria mai, who turned it into a Māori version instead of an English version, they set it to one particular tune. But over time, someone was like, oh, well, that's all well and good, but have you noticed that you could sing it this way instead? And so they would have sung it that way. They would have recomposed it and sung it a different way. That's the mutation. That's the change. So it helps if you can get away from mutations, thinking about them as negative things, and start thinking about them just as a change, a new idea that your genes have had. And it's not like your genes pick the mutations. They're a completely random process. But just like with whakaria mai, someone had a new idea. Oh, let's sing whakaria mai to a different tune. And now the two tunes exist side by side. Sometimes you'll hear whakaria mai sung this way, sometimes you'll hear it sung this way. Now the reason I chose whakaria mai as the example is up here in Patuharakeke, you almost always hear it sung this way. But until I'd moved up here, I'd never heard it sung to anything other than this tune. So this variant of whakaria mai is really common here, but it's not common throughout the rest of the country. So that also happens with alleles, and you can think of eye colour as a really good example. Eye colour started as a mutation in Northern Europe, where there wasn't a lot of sunlight. If blue eyes had been like a mutation in Africa, say, if you don't have enough melanin in your eyes, it's not great for your eyes. But in Northern Europe, you don't need a lot of melanin. There's not as much sun as in the plains of Africa. So that variation endured, and over time it became established as an allele. So it originally was just one variation in one person. And if it occurs in their sex cells, it's able to be passed on. So they had a mutation in an egg or in a sperm that said, hey, let's not make so much melanin in our eye cells. And the baby was born with blue eyes. That must have been revolutionary the first time it happened. And then it went on and it started to spread because it didn't cause any harm. If mutations are harmful, hopefully the offspring will not breed, and therefore the mutation never spreads. Okay, that's the goal of nature, is that harmful mutations can't spread because the offspring won't go ahead and breed. They won't be fit for breeding. Sometimes they are, and the mutation can spread anyway, harmful or not harmful. Sometimes a mutation is helpful. So an example of this might be in our flower, maybe one of those babies has spikes, and that discourages animals from eating it, and that's an advantage. That's an advantageous mutation. So variation is caused by mutations. Mutations change something about the DNA. So they might swap a bit of DNA from one place to another. They might flip a bit of DNA over, but they change something in the DNA. And this makes a change in either the type of protein being made, where the protein is made, or how much is made. And so eye colour is a classic example of this, because there is a variation for blue eyes. Blue eyes make the same protein. They make the protein in the same cells, but they don't make as much. That's why eyes appear blue. Brown eyes, they still make melanin, that protein. They still make it in their eye cells, but they make a lot more, and that's why the eyes appear brown. So, key things from this one. Our genes can come in variations, and those variations are called alleles. So, flower colour is the gene. The allele is either pink flowers or red flowers. This variation is caused by mutations. Mutations can be helpful, harmful, or neutral. And the mutations change something in the DNA. When they change something in the DNA by flipping a bit of the DNA or cutting a little bit of the DNA out or shifting it from one chromosome to another completely, it makes a change in either the type of protein, which cells make the protein, or how much of the protein is made. Okay, and if these are beneficial or they're neutral, over time they can spread throughout the population, and that's what causes genetic variation.